Hello, good morning everybody. In topic of kinematics linear motion, there are three functions of time which are displacement, velocity and acceleration. Here we are going to discuss all questions related to this topic from textbook KSSM Formative Exercise 8.3. Okay, so question number 1. A particle passes a fixed point O with an initial velocity of 30 meters per second and moves along a straight line with an acceleration A equals to 12 minus 60 meter per second squared, where it is the time in second after passing through the point O. So A, calculate the velocity in meter per second when t equals to 2. Okay, so the three component SVA, so S to V, differentiate V to A, differentiate A to V, integrate. Okay, another time. This one integrate another time. Okay, so now we start from A equals to 12 minus 60. Okay, initial velocity 30, so meaning that when t equals to 0, V equals to 30. Okay, so we are going to find the velocity. Okay, velocity from A we need to integrate. Okay, so V is integrate A, 12 minus 60 with respect to t. So V equals to 12 minus 60 squared, 12t minus 60 squared over 2 plus c. Okay, so then c is initial velocity which is 30. Okay, so 30 is 12 times 0 minus 3 times 0 squared plus c. So c equals to 30. So therefore V equals to 12t minus 3t squared plus 30. Okay, so we are going to find velocity when t equals to 2 into V. Okay, so when t equals to 2, V is 12 times 2 minus 3 times 2 squared plus 30. Okay, which is equals to 42 meter per second. Okay, question B. Where is the particle when t equals to 1? Okay, where? Where meaning that we are going to know where is the position of the particle. Then position related to displacements, where we need to find the displacement. Okay, so now to find displacement S, okay, from V we need to integrate another time. So S is integrate this one. So 12t minus 3t squared plus 30 with respect to t. Okay, so S equals to 12t squared over 2 minus 3t cubed over 3 plus 30t plus c. Okay, so then assume c equals to 1. So when t equals to 0, S equals to 0, c equals to 0. So then S equals to 6t squared minus t cubed plus 30t. Okay, so this is function of displacement. So where the position when t equals to 1, so we substitute t equals to 1 into S. So 6 times 1 squared minus 1 cubed plus 30 times 1. Okay, this one equals to 35. Okay, this one equals to 35 meter. So meaning that when t equals to 1, the particle is 35 meter to the right. Okay, so 35 meter to the right of point O. Number 2, a particle moves along a straight line and passes through a fixed point O. At t seconds after passing O, its velocity v meter per second is given by v equals to 24t minus 60 squared. Okay, so the function of v. Okay, calculate the initial acceleration. So S, VA, differentiate, this one integrate, this one integrate. Okay, so now we are going to find initial acceleration, meaning that acceleration from V, we need to differentiate. So A is dv dt, okay, gradient of velocity. So, A equals to 24 minus 12t. So this is function of acceleration. So initial acceleration, meaning that t equals to 0. So t equals to 0 into A. So 24 minus 12 times 0, which is equals to 24 meter per second squared. Okay, B, the value of t in second when the acceleration is 0. We are going to find t. Okay, so acceleration is 0. A equals to 0. A is this one, 24 minus 12t equals to 0. Then t equals to 2 seconds. Okay, the last one, the value of t. Okay, we are going to find t when the particle is at O again. Okay, at O again. So at O again, so the position of the particle is at the starting point, which is 0. So meaning that S equals to 0. Okay, so now we don't have S. We need to find S from velocity. Okay, so then we need to integrate. Okay, find S from velocity, integrate V. So S equals to integrate this one, 24 t minus 60 squared dt. Okay, so 24t squared over 2 minus 60 cubed over 3 plus c. Okay, so simplify 12 to. Okay, so S equals to 12t, we assume c is 0. So when t equals to 0, S equals to 0, then c equals to 0. So S equals to 12t squared minus 2t cubed. Okay, so this is the function of displacement. Okay, so S equals to 0. Okay, at O again. Okay, at O again. So S equals to 0. So this one, 12t squared minus 2t cubed equals to 0. Then this is quadratic equation. We need to factorize to solve. So 2t squared, 6 minus t equals to 0. Then t equals to 0, t equals to 6. Okay, since of at O again, okay, so we need to choose t equals to 6 seconds. So t equals to 6 seconds. Question 3, a particle moves along a straight line and passes through a fixed point O with a velocity of negative 12 meter per second and acceleration of negative 10 meter per second squared. After t seconds of passing the fixed point O, the acceleration of the particle is A equals to m plus nt. So A equals to m plus nt. Where m and n are constant, the particle stops instantaneously when t equals to 6. Calculate the values of m and n. Okay, so S, V, A, S to V, differentiate V to A, differentiate A to V, integrate V to S, integrate. Okay, so now we are going to find M and N. So given from the information, when the particle passes through fixed point O, velocity negative 12, acceleration negative 10. So meaning that when t equals to 0, initial velocity is negative 12. And when t equals to 0, initial acceleration, A equals to negative 10. Okay, so to find M and N, so we substitute the first one A, negative 10. So negative 10 equals to M plus N0. So M equals to negative 10. Okay, so A equals to negative 10 plus NT. Okay, so then velocity. Okay, from A to find velocity, we need to integrate. Okay, so negative 10 plus NT with respect to T. So V equals to negative 10T plus NT squared over 2 plus C. Okay, so initial velocity is negative 12, meaning that C is negative 12. Okay, so C equals to negative 12, so V equals to negative 10T plus NT squared over 2 minus 12. Okay, so now given more information here, particles stop when t equals to 6. Okay, stop V0 when t equals to 6. Okay, V0 t equals to 6. Okay, so we substitute into function of v. V is 0. Negative 10, 6 plus n 6 squared over 2 minus 12. Okay, so then we solve this one. Okay, so become this one 60 plus 12 equals to 18n. So n equals to 4. So then m equals to negative 10, n equals to 4. 3b, we are going to find the minimum velocity in meter per second of the particle. Okay, so from question A, we already have m is negative 10 and n equals to 4. So we substitute into function of acceleration. So is m negative 10, n is 4. Okay, so this is acceleration. Okay, so then velocity v equals to negative 10t plus 2t squared minus 12. Okay, so this is function of velocity. Okay, so B, minimum velocity, minimum V, A equals to 0. So negative 10 plus 4t equals to 0, then t equals to 5 over 2 seconds. Okay, so to find minimum velocity, we substitute into V. So V minimum, negative 10 times 5 over 2 plus 2 times 5 over 2 squared minus 12. Okay, which is equals to negative 24, 1 over 2 meter per second. Question C, find the total distance in meter traveled by the particle in the first 9 seconds. Okay, total distance in the first 9 seconds, meaning that from t equals to 0 to t equals to 9. Okay, in between we need to test either the particle change direction or not. Okay, so meaning that we have to test v equals to 0. Actually, given from the question, v0 stop, the time is t equals to 6. Okay, so t equals to 6, meaning that affect the movement of the particle. Okay, so then we need to find all these values of t into s. Okay, into displacement, because we are going to find the distance. Okay, so find s first. So s is integrate v. Okay, so v is 2t squared minus 10t minus 12. I rearrange. Okay, so then s equals to 2t cubed over 3 minus 10t squared over 2 minus 12t plus c. Okay, so when t equals to 0, s equals to 0, then c equals to 0. Okay, so then s is 2 over 3 t cubed minus 5t squared minus 12t. Okay, so this is function of displacement. Okay, so then we need to substitute all values of t. So t equal to 0, s equals to 2 over 3, 0 cubed minus 5 times 0 squared minus 12 times 0, 0 meter. So when t equals to 6, s is 2 over 3, 6 cubed minus 5 times 6 squared minus 12, 6, which is equals to negative 108. Okay, so when t equals to 9, s equals to 2 over 3, 9 cubed minus 5, 9 squared minus 12, 9 equals to negative 27. Okay, so then we are going to draw all these values in the number line. Okay, so then don't forget when v equal to 0, stop. This one change direction. Okay, the particles change direction at s equals to negative 108. Okay, so then we draw on the number line. So this is 0. So negative 108 at the left because negative, then negative 27 more than negative 108 but less than 0. So right here. Okay, when t 0 as 0. When t 6 as negative 108. At this time, the particle change direction. Okay, so t equals to 6. And when t equals to 9, the particle is at 27 meter to the left. Okay, so this one when t equals to 9. Okay, so then total distance. Okay, total distance travel. So total distance in the first 9 seconds. Okay, meaning that 108 plus 108 minus 27. Okay, which is equals to 189 meter. Question number 4. A particle moves along a straight line from a fixed point O. Its velocity, v meter per second, at t second after leaving O is given by v equals to 2t squared minus 5t minus 3. Okay, so this is the function of velocity. Okay, so then calculate the displacement in meter when the particle stop instantaneously. Okay, so the relation between these three components. So S to V, differentiate, V to A, differentiate, A to V, integrate, V to S, integrate. Okay, so now we are going to find displacement. Then V to find displacement, integrate. Okay, so sorry. S equals to integrate 2t squared minus 5t minus 3. Okay, so this one 2t cubed over 3 minus 5t squared over 2 minus 3t plus c. So when t equals to 0, s equals to 0, c equals to 0. So s equals to 2 over 3 t cubed minus 5 over 2 t squared minus 3t. Okay, so particle stop instantaneously. Okay, stop, v equals to 0. Okay, so stop, v equal to 0, then 2t squared minus 5t minus 3 equal to 0. Okay, so this one we can factorize. So 2t plus 1 minus 3. Okay, so then t equals to negative 1 over 2, t equals to 3. Okay, so since of t is always positive, we choose t equals to 3. Okay, into s, into displacement. So this one equal to 0. Okay, so when t equals to 3, s equals to 2 over 3, 3 cubed minus 5 over 2, 2 squared minus 3 times. Okay, this one 3 should be 3, sorry. This one 3. Okay, so then the answer is negative 13.1 over 2 meter. For B, find the range of time in second when the particle decelerates. Okay, decelerate. Then A is less than 0. Okay, now we got V, so we need to find A. Okay, so A is dv dt, gradient of velocity. So A is 4t minus 5. Okay, so this is function of acceleration. So acceleration is less than 0. Okay, so 4t minus 5 less than 0, then t less than 5 over 4. Okay, since all t is time, always positive, so we need to limit these two, must be more equals than 0. Question 4c, find the total distance in meter traveled by the particle in the first 6 seconds. Okay, total distance first 6 seconds means from t equal to 0 to t equals to 6. Okay, so then we have to test v equal to 0. Okay, v equal to 0, we already have from question A. When v equals to 0, t equals to 3. Okay, so then we need to substitute all these values of t into displacement because we are going to find the total distance. Okay, for question A as well, you already have S. So S is 2 over 3 t cubed minus 5 over 2 t squared minus 3t. Okay, this is the displacement, function of displacement. So we substitute t0 as 2 over 3, 0 cubed minus 5 over 2, 0 squared minus 3 times 0, which is equals to 0. Okay, then when t equals to 3, s equals to 2 over 3, 3 cubed minus 5 over 2, 3 squared minus 3 times 3. Okay, this one equals to negative, already have as well this one. T equals to 13, 1 over 2 from question A. Okay, so then when t equals to 6, s equals to 2 over 3, 6 cubed minus 5 over 2, 6 squared minus 3 times 6. Okay, equals to 36. Then we mark all these values of s into number line. Okay, so 0, negative 13 at the left, 36 at right. Okay, when t 0, s 0. When t 3, s negative 13 and half. Okay, this one the particle change direction. Okay, so this one when t equals to 3. When t equals to 6, right here. This one t equals to 6. Okay, so then to find the total distance, okay, so 13, 1 over 2, this one, okay. From here to here, 13, 1 over 2. From here to here, 13, 1 over 2. From here to here, 36. Okay, then we add all. So 13, 1 over 2 plus 13, 1 over 2 plus 36. Okay, which is equals to 63 meter. Number 5, Haikal placed a remote control car along a straight track. The acceleration a meter per second squared of the remote control car is given by a equals to 12 minus 40. Okay, so where t is in second after the remote control car passes a fixed point O. Calculate the maximum velocity in meter per second of the remote control car. Okay, so SVA, okay, differentiate. This one differentiate, this one integrate, V to S integrate. Okay, so then to find maximum velocity A equals to 0. Okay, so maximum V, A equals to 0, 12 minus 40 equals to 0, 3 equal to t second. So we need to substitute t equals to 3 into velocity. Okay, velocity, to find velocity from acceleration, so we need to integrate 12 minus 40 dt. So v equals to 12t minus 40 squared over 2 plus c. Okay, since of no information given from the question, we assume t equals to 0. So when t 0, v 0, c equals to 0. Assume c equals to 0. Okay, so then v is 12t minus 2t squared. Okay, so V maximum when t equals to 3. So substitute t equals to 3. V equals to 12 times 3 minus 2 times 3 squared. Okay, which is equals to 18 meter per second. 5b, find the values of t in second when the velocity of the remote control car is 0. So velocity is 0. So V is 0 from previous question. V is 12t minus 2t squared. So equals to 0. Then factorize factorize 2t. Okay, then 6 minus t equals to 0. T equals to 0. T equals to 6. Okay, both values of t. Okay, C. Find the distance travel in meter of the remote control car in the 5th second. So meaning that from t equals to 4 to t equals to 5 into s. Okay, so we need to find s from velocity. Integrate velocity, this one, 12t minus 2t squared with respect to t. So s is 12t squared over 2 minus 2t cubed over 3 plus c. Okay, so then we assume when t equals to 0, s equals to 0, c equals to 0. Then S equals to, we simplify this one, 6t squared minus 2 over 3 t cubed. Okay, so this is function of displacement. Okay, so then just now we already have T4 to T5. So we need to substitute into S. So when T equals to 4, S is 6 times 4 squared minus 2 over 3, 4 cubed equals to 53, 1 over 3. And when T equals to 5, S is 6 times 5 squared minus 2 over 3, 5 cubed. Okay, equals to 66, 2 over 3. Okay, so to find the distance traveled in the 5th second, so distance equals to 66, 2 over 3 minus 53, 1 over 3. Okay, which is equals to 13, 1 over 3 meter. Question number 6. The diagram on the right shows Azlan running across a straight bridge in 25 seconds with a velocity v meter per second. His velocity t second after passing through M is given by v equals to 3 over 40 minus 3 over 100 t squared. Okay, so calculate the value of t in second when the acceleration of Azlan is 0. So as VA differentiate, differentiate, this one integrate, V to S integrate. Okay, so now A acceleration 0. So A is dv dt. So we differentiate, we got 3 over 4 minus 3 over 50t. Okay, this one equals to 0. So 3 over 4 equals to 3 over 50t. Then t equals to 25 over 2 second. Okay, B maximum velocity in meter per second of Azlan. Okay, so max VA equals to 0. Okay, so now we already have when t 0, t equals to 25 over 2. So then we substitute t equals to 25 over 2 into velocity. Okay, so when t equals to 25 over 2, V equals to 3 over 4 times 25 over 2 minus 3 over 100. 25 over 2 squared, okay, which is equals to 75 over 16, okay, meter per second. See the total distance in meter traveled by Azlan. Okay, so total distance now given from the question, Azlan running in 25 seconds. Okay, so meaning that when t equals to 0 to t equals to 25. Okay, so then when we test, okay, v equal to 0. Okay, v equals to 0. Just now v is 3 over 4 t minus 3 over 100 t squared. Okay, so 3 over 40 minus 3 over 100 t squared equals to 0. Then this one we can factorize 3t over 4, 1 minus t over 25. Okay, equals to 0. Then t equal to 0, t equals 25. Okay, so meaning that the Azlan change direction at t equals to 25. Okay, so then does not affect the movement of Azlan. Okay, so we just substitute t equal to 0 into S and t equals 25 into S. Okay, so the issue is we don't have S, so we need to find S first. Okay, so to find S, integrate V. V is 3 over 40 minus 3 over 100 t squared. Okay, integrate with respect to t. Okay, so this one 3 over 4 t squared over 2 minus 3 over 100 t cube over 3, okay, plus c. So assume c 0 when t equals to 0, s equals to 0, c equals to 0. So s is 3 over 8 t squared minus 1 over 100 t cube. Okay, so this is function of s. So then when t equal to 0, s equals to 3 over 8 times 0 squared minus 1 over 100, 1 cube, okay, which is equals to 0. And when t equals to 25, s equals to 3 over 8, 25 power of 2 minus 1 over 100, 25 power of 3. Okay, so this one 6 to 5 over 8 meter. Okay, so then the total distance by Azlan equals to 6 to 5 over 8 minus 0, which is equals to 6 to 5 over 8 meter.